don't think number 4 is too bad. If you remember the concept of patterns that I talked about in the video, I'll put it like this. With number 4, dy dx depends only on x, right? Therefore, you should have what kind of pattern?
A vertical.
Vertical, yeah. So once you start to get the vertical pattern figured out, it should go relatively quickly on your slope fields. So consider that. These slope fields do show up on free response questions sometimes, and I kind of feel like once you guys get the hang of these, they're not too bad to do. Last year it showed up on the free response question, the AT test, and so I kind of feel like it's a pretty easy 2 points, right? You can draw a slope.
This is a free response question?
Should be in good shape. I'm doing good. I don't know if I can speak for everybody.
This is a free response question?
Sometimes, yeah, this will be involved in a free response. It won't be the whole thing. It'll be part of a free response, so, yeah. So I welcome those situations. I think that would be a good thing. And start making my slope field here for number 4. Just kind of explain how I would do this. On the video, I know that I made a little table. I'll do something similar to that here. The input would be x.
Can you please have Tiffany Parabak come to the front desk, please? Thank you.
Okay, so, like I said, the good news about something like this is you get that nice vertical pattern. So things like this would be pretty easy to do efficiently knowing the pattern. You know that if x is 0, dy dx is 0. And so since dy dx, we're talking about slope, that would be little horizontal tick marks right when x is 0. So when x is 0, that is the y-axis. And so I'm just going to put little horizontal tick marks all along here, like so. And once you see that pattern, you could just fill in a whole column, right? Or in other cases, a whole row. So, moving on, if x is 1, then 1 times 2 is 2, so dy dx is 2. And I think I mentioned in the video, trying to do a slope of 2 is kind of challenging. Definitely on a quiz or a test situation, I'll give you a ruler if you would like to use a ruler. What I would do if I was using a ruler, I would line this point up with this point right here, and that would give me a slope of 2, wouldn't it? And so, in trying to do that, if I line those two up, it'll look something like that. And then knowing that vertically I'm going to have that pattern, I'm just going to try to mimic that slope. So I don't like that one very much.
Would you count wrong for like a little, it's like every little
We'll talk about that in a second. That's a good question. So, pretty consistent there, right? When x is 2, dy dx is 4. I kind of feel like once you get up to about that 4 or 5, it gets really hard to draw because it starts looking more and more vertical. Because truly for a slope of 4, if I was going to try to draw a slope of 4 right there, I'd have to go down 1, 2, 3, 4. So I'd have to line it up with that point right there, wouldn't I? So using a ruler would actually make this a little easier, especially in this case. It's just going to be super duper steep. That's probably not quite steep enough. Something like that. I guess I feel pretty good about that. It's clearly steeper than when x is 1, right? It's supposed to be twice as steep. Tough to draw. I think I would probably forego that right column because when x is 3, dy dx is 6, that's going to appear to almost be vertical. I don't know. So I don't know if this is going to be hard to draw. That's actually, except for maybe that last one on the bottom right, that's pretty good. It's hard to draw those. Very difficult to draw. If you do some negatives, right, you're going to get -1 for x. dy dx would be -2 as you plug in and get an output there. So -2 is just going to be going downhill from left to right. So I'm going with something like this. Looks fairly symmetrical. And then when x is -2, you get a slope of -4. So those little tick marks are going to be similarly steep in the negative direction, like that. And then, the ones on the far left, again, very difficult. Slope of -6. That is clearly not good. I don't know. This is tough to do. So while I'm finishing this up, let's talk about grading. Dixon asked, that's actually one of my better slope fields. I'm actually mildly happy with that. So Dixon said, how is this graded? So what I'm not going to do is this. I'm not going to get out a protractor and say, I'm sorry, Ben, it should have been 74 degrees. Yours is only 71 degrees. And so it's -1 point. Not going to go there, right? Because just like the burden of precision is just too much, to get every single tick mark within the right degree range. So what I'm typically going to be doing is, I feel like horizontal slopes should be very horizontal, right? Bless you. So, I would look at something like this and say, hey, all these slopes that are on the x-axis, or the y-axis, excuse me, really, need to be clearly horizontal, right? I need to look at them and I need to say, without getting out the protractor, say, yep, those are very horizontal. And then when I would look at the right half of the graph, I would say, do I see a pattern where as I go to the right, we're getting steeper? That makes sense? So like the slope when x is 3 needs to be significantly steeper than the slope when x is 1 or 2, right? So I'm going to be looking for more of a pattern than anything else. And also, all the slopes on the right half of the graph have to be positive. And so if you had some that somehow were negative, like that's an obvious error, right? And then similar line of thinking on the left side. So, so there's a lot of leeway there, right? Looking for correct patterns within those slope fields, but not necessarily looking for like precise angles. Make sense? Okay. And I think you'll find that slopes that are like 1/2, 1, maybe 3/2, -1/2, -1. Those are pretty easy to draw. It's when you get into like if you have like a slope of like 1/5 or 5. Those are much more difficult to draw. Well, I think a ruler would be helpful. So I'll offer those to you when it comes time for a quiz or test. You don't have to use them, but you're welcome to it. You could always use the calculator cover, calculator side, whatever works for you there. Okay, so slope fields. Walking around, I saw a lot of folks had the first part filled out. Tells me that you attempted, to learn from the video. That's awesome. You got a chance to practice it right here. We're going to stop right there for now, and we'll pick up the rest of this and do a lot of this on Friday. So, any questions on that before we put it away for now? Okay, fair enough. So, we're going to do a little review of you could see something like this very easily. Like if you saw integral of, I don't know, e, let's see here, I'll do it like this. Let's say what you mentioned, e to the tangent of x. I'll make it a little more interesting. E to the 5 tangent of x. If I was going to write a good question, the other factor would have to be some version of that.
Yeah.
Right? So this would be an okay question, right? So you'd look at something like that and you'd say, clearly the composite part of this, like the more involved composite is the e function, right?
Yeah.
E to the 5 tangent of x. And so then you'd ask yourself, all right, well, if that's what it is, then I need to make sure that the derivative of the inside is the other factor. So, maybe you almost approach it like a substitution. So you say u equals the inside, and then you say, well, then du is equal to 5 secant squared of x dx. And then you say, all right, well, is this going to work out substitution-wise? I think it will. I could look at this and just probably do a Timmy messed up the chain rule scenario at this point, and say, well, the other factor is secant squared of x dx, which is exactly what I want other than the 5.
Yeah.
And so why not just throw a 5 in there to fix Timmy's error, and a 1/5 on the outside. So you'd end up with 1/5. And then what is the antiderivative of e to the u du?
It would be e to the u times u prime.
No,
Oh,
just e to the u.
Oh,
It's just
it
e
would
to the
be
u.
a derivative.
Yeah, I think you were doing a derivative, yep. So this just goes back inside. This just goes back inside, and the antiderivative of e to the u is just e to the u. So this would end up being 1/5 e to the 5 tangent of x plus c. So something like that is very possible. I mean, you could even, there's all kinds of varieties, and I think this is where, I think this is very much worth talking about. You could have varieties like this. Like what if you had, this, you could have e to the whatever, as long as it's something we've done.
Yeah.
I mean,
E to the Google infinity sign or something.
that's a little strange just because of the infinity sign. But, you could have e to a polynomial.
That's way out there.
We've done polynomials, right? Could be a trig function. It could be some log function, I suppose, right? If it was ln, then I'd assume you'd simplify before you messed around with it too much. But it, could be a variety of things. Really could. Arctangent, how about? That would be really complicated looking. But if you know your patterns, you'd see it pretty quick. It wouldn't be that bad. So, any other questions like that? Any other questions at all? Okay, so if there's not, here's what I want to do. And I mean this literally, like in a very nice way, I want to mess with you. and see if I can get you to think. So everything I'm about to show you is totally out of context, right? All I'm going to tell you is that these are going to be integrals, integrands that have some fractions in some form or fashion, and it's going to be up to you to decipher. It might be easy, it might be difficult, I don't know. We'll find out how it goes for you. So I'm just going to throw some up here and see what you come up with as far as what you think it is. You can try to figure out the form, you can try to take it all the way through, and whatever. So here we go. I'm making a video of this for those that I think everybody's here now, right? Is everybody here? Everybody's here. But maybe the other class somebody will be absent. You can go back and watch
You
this
won't give
yourself.
us the equations like the arctangent, right?
No, you need to know those. Yep, you need to be able to reason with those. Okay, so let's say we had something like this. Think about what that is. And once you have maybe arrived at what you think it is, go ahead and try to execute it. See if you can take it all the way through to an antiderivative with a plus c. Order, is it going to be ln, flip up, arcsine, or arctangent? It's definitely ln. It is. We'll talk about your reasoning on that too. I tried to make it look like something else, didn't I?
Yeah.
I told you I'd mess with you, right? I'm going to try to make things look like other things to get you to think, as opposed to just being an automated math machine, you know, that doesn't think. If you think these through, you can get them, right? But it's not going to be easy. So my way of thinking about this, like as I thought about this question, my first thought is we got to get the 3 out of there. That's sort of a, I hope that at this point it's just sort of a fundamentally, you know, early thing that we'll always think about doing. So you get to this point with that constant multiple pulled out. And I really do want you to do this. We can make a little checklist if you want. I don't know if that works for you. Flip up, there we go, and then arcsine, arctangent. Go through this little checklist right here. I really think you should consider strongly ln before you consider anything else. So when you're thinking about ln, the key question to ask is this. Looking at the integrand, is the derivative of the denominator the same thing as the numerator?
Yes. You just have to
Well, it's not, but it's a minor error with a constant multiple, right?
Yeah.
And so the derivative of the denominator is 2x. The top is x. So since we're only off by a factor of 2, that just means the du is a little bit off, right? So all we do is we multiply the top by 2, and we divide the outside by 2. So it was this, so we don't have to go any further. It wasn't any of these. And once we've done this, the integrand perfectly fits the chain rule pattern for a natural log. And so our answer would be 3/2 natural log of the denominator. I am not going to put absolute values here. Do you guys know why? I don't really have to. There's no way that x squared plus 25 can be negative, right? You could. Yeah, putting them in there is not going to be wrong. I just think they're redundant. But putting them there will be totally correct. Definitely.
Could we do a word problem? Because I kind of think like I'm going to get confused with something like that with these.
So when you say, can we do a word problem, can you be... We're looking at this. This really would be like using an old application style question using details from now. So this, I hope, like if you truly, do this by hand up until the very, very end, this will be a really handy question for you, I think, for our current material as well. So this could easily be a quiz question. I can tell you right now, this is not an exact quiz question, but it could be. Could be. Maybe next year students will get this exact question.
3 instead of 1/3?
Yeah, so I think the confusion from that arises with confusing two distinctly different things. So let's just take this over here, and I'll just write it like this: 1 over 1 plus t squared dt. Like, how do you handle that, right? So where we run into problems is this. I find when people forget to get any constant multiples out, we start asking questions like that, right? You should always get the constant multiples out before you consider anything else. Because I can see why you would think that, right? So I hope this doesn't confuse you. But since you asked, we've had a lot of questions along those lines. I'm going to show you two ways. Do I want to do this? I'm going to do this just with you later, okay? Let me show you the way that I want you to do this. I'm not going to show you an alternative because I don't want other people to be like, wait, what you said. So just get the constant multiples out. So what you would write is 3 integral 1 over 1 plus t squared dt. That's like one distinct, unique action. Now you ask yourself, essentially, did Timmy mess up? These are two different thought processes. The first one is just like, get it out. The second one is a little deeper analysis where you say, hey, is the derivative of the bottom of the top, or does it fit the arctan pattern, or is it a flip up? You ask those sorts of questions. So the 3 is out, so we totally ignore the 3 and just look at this. And we say, okay, is it ln? Nope, because we'd be missing a factor of t in the top, right? So it's not ln. It's not flip up either for similar reasons. So is it arctan or arcsine? It's arctangent because there's no square root and it's a plus instead of a minus. And then we'd go through a little deeper analysis and say, all right, if it really is going to be arctan, u would have to be t, a would have to be 1, and u prime would be 1, right? So the top, to make this work, needs to agree with what we've selected for our u and our a. So the top is supposed to be u prime times a, which in this case, the way we've set it up would be 1 times 1, which is 1. It's all perfectly set up, so it just ends up being arctangent of t over 1, and the 3 was there all along. So it'd be 3 arctangent of t.
I think what I did at first was, I left the 3 up there,
Yep.
and then found out that, u prime times a.
You tried to turn it into a 1. Yeah, so that's an alternative approach. I get that. And I would be happy to talk to you about that, because, I don't know, for you, maybe that somehow that would be the better way to go. For some people, maybe that would. But I don't want to confuse everybody potentially with an alternative method,
We
because
do this, like, method for 5-1 to 5-3, you know how we have to solve for, we should always recommend taking it in.
get the constant multiples out every time. If it's a constant multiple, get it out. Yep. Okay, good question. Anybody else? Okay, let me continue to try to just mess with you a little bit, see how it goes. So let's do this.
I'm just trying to like memorize stuff in my up to here and then.
Don't memorize flakes, please.
Okay, ready, go. Try that one.
You know what? That's so easy.
Ask you to go through this mental checklist. ln, flip up, arcsine, arctangent, that sort of thing. So when you look at this and you ask yourself, is it ln? What tells you that it is definitely not ln? Like, what's the number one symbol?
It's not u prime over u.
For that specific one, square root. Square root ruins ln. If the square root's not there, it's for sure ln. The square root being there or not completely changes the form of your antiderivative. Okay, so it's not ln, so we cross that off the list. Next, you ask yourself, all right, is it flip up? I would ask you to like either mentally do this or actually physically do this on your paper. Say, let me try flip up and see if it works. So maybe you flip up and you write something like this: 9 minus t squared to the negative 1/2 dt. What's the question you got to ask yourself to determine if this works or not?
Well, it'd be 0 over 0.
Is it off?
Yeah, the inside-outside thing, right? Yeah, so you say, is the derivative of the inside of the composite the same thing as the other factor? It's not, but it's close enough, isn't it? Because the derivative of the inside is negative 2t. The other factor is just t. We can fix that, can't we? So we just multiply the negative t, the inside here, by negative 2. We multiply the outside by negative 1/2. So this is a flip up. What did I try really hard to make it look like?
Like it was arcsine.
I tried to make it look like an arcsine, but the fact that the top was a t versus a 1 or some other constant means that it is not arcsine. It's actually a flip up. Do you see why you need to actually be analyzing this instead of just a brief glance at the form and be like, it's that because it looks like the thing in my notes. You've got to ask yourself the right questions. So this would be negative 1/2 times, and then for this it would be 9 minus t squared, just a power rule, to the 1/2 times 2 plus c. So a great comparison and contrast, if you wanted to, would be this. if you had one integral that was this right here that we have, and then another integral that was this, the one we just did, of course, would be a flip-up power rule, and the one on the right would be an arcsine. And so you want to be very careful that you analyze deeper than just, I saw a square root and a minus. It must be arcsine.
So there, it can't be arcsine of a variable on the top.
You could. Check this out. This is also arcsine. That would kind of go against what you said. So if we had integral of t over 9 minus t to the fourth, that would be arcsine. Let's talk about why. If that's going to be arcsine, what would your a value?
3.
It would be 3. What is your u value?
T squared. T squared.
U prime then would be,
2t.
and the top is supposed to be u prime.
So
2t.
it's just off by
You're off by a factor of 2. So that's why I'm saying let's be really careful about avoiding memorization and focusing on analysis and asking the right questions, right? Is this this? Is this that? Instead of just looking at a form and making a snap decision, look at it and ask yourself the right questions. You should arrive at a good place. If you really do ask those good questions, you should be okay. But if you're like, nah, don't need to, you could easily fool yourself, right? You could turn something into something that it's really not.
On the problems when we have the denominator equal to 0 on like a flip up, if we, like say we mistake a problem and say, oh, I can flip this up.
Yep. And you get the whole divided by 0
What
thing.
would that look like?
So if you had,
I think it was like, we could use like the last one.
yeah, well, let's see here. Like if you had, there we go, integral of, I don't know, 3t over 5 plus 10t squared maybe. If you just blasted right on through ln, and this is going to be an ln, but if you did blast right past ln and you flipped up, you would get this. Maybe you get the 3 out of there, 5 plus 10t squared to the negative 1. If you find yourself flipping up and writing to the negative 1, that's going to be your first clue, right? But if you don't notice that, you'd be like, well, I'm off by a factor of 20, right? Because it should be 20t on the other factor, so times 20, so over 20. And then you'd be like, all right, 3/20, 5 plus 10t squared to the negative 1 plus 1. Oh, gosh, that's 0. Divided, oh, that's really bad. So if you find yourself doing that, you probably need to go back and say, was it really ln? Because it probably was. But if you flip up and you write to the negative 1, that's got to be your first hint that we're about to run into problems. Okay, can I throw another one or two at you? Okay, here we go. Let's go with this. Integral of 1 over square root negative x squared minus 2x plus 35 dx. Don't you guys have something bad for breakfast or something? Your stomach hurt?
Yeah, all finish at the same time.
You all had the same thing at the same place at the same time. Yep, okay. Sorry for my messy square root there, but I wanted to make sure it was covering everything it needed to cover. Okay. The thought process is this. You ask yourself, is it ln? And there's many reasons to reject ln, not the least of which is the square root, right? That would ruin the idea of ln. Too many terms. It's not ln. Flip up. Similar reason. If you flipped up, you would say, wow, what's the derivative of the inside? It would be negative 2x minus 2. The only other factor is a 1 dx. I mean, so it's definitely not flip up. And so then you're left with arcsine or arctangent. And this does not look like either one of those, at least at first glance, right? But the square root should tell you that if it's going to be one of those two, it's going to be arcsine, right? And then you look at the inside and say, well, the inside doesn't look right either, and so that tells you that you need to complete the square, everyone's favorite. It's not that bad. Let's look at it really quick. Complete the square. Here's how it works. Negative x squared minus 2x plus 35. What I'm going to do is group the first two. I'll leave a little space in the next step as well. The trick about these is that negative a value is not good, right? I'm going to factor out the negative a value. So my next step would be this. Negative parentheses x squared plus 2x plus 35. And then we focus on the b. The b value is 2. And so we take half of b, which is 1, and we square it, which gives us 1. I take that 1 and I add it to the inside. But I didn't really just add it, did I? I really just subtracted it, so to balance it out, I go plus 1 here. This gives me negative, when I factor this, it's x plus 1 squared, and then plus 36. So you go back, and you say, all right, now it's 1 over square root of 36 minus x plus 1 squared. And you ask yourself what your u and your a would be. Wouldn't your a be 6?
Yes.
And your u would be x plus 1?
Yes.
The top is supposed to be u prime, and it matches, doesn't it?
Yes.
So this is perfectly set up for arcsine. So this would end up being arcsine of x minus 1 over 6 plus c. Or plus 1, sorry, plus 1. Plus c. Yeah, plus 1. That was just a mistake. Okay, so I'll see you for your quiz tomorrow. Please practice up. WebAssign due tonight.
You said you're in here during lunch.
During lunch?
During lunch.
Yeah.